All right, we're on to 12.3, page 715, having to do with kind of an introduction to some basic probability. And we're going to look at numbers 8, 10, and 12 here on this side of the board, maybe a couple others on the other side. So number 8, we have a situation, well, all of these three problems here, 8, 10, and 12, have to deal with a family having 3 children. It says, assume it is equally likely for a child to be born a boy or a girl, and that the Lin family is planning on having 3 children. So this is very similar to the heads and tails question we did. I think it was in 12.1 or 12.2, where after one child, well, you either have a boy or a girl, right? So 2 choices, boy or a girl. We're saying equally likely. After the second child, well, if you had a boy on the first child, for the first child, you can either have a second boy or a girl. If you had a girl, then you could have a boy or a girl, right? So now you got 4 different possibilities after your second child. And just like we did before, these branch out now 2 for each of these 4, and we end up with these 8 possible outcomes after 3 children. You could have all boys, you could have 2 boys first and then a girl, and you can see the different outcomes here. A boy and then 2 girls, a boy, a girl, and a boy, and so forth, or 3 girls. So there's 8 possible outcomes. 2 times 2 times 2 give us these 8 possible outcomes. So for number 8, we are asked to come up with the sample space for the case where the Lins have 2 boys and 1 girl. List the elements of the event that the Lins have 2 boys and 1 girl. Well, we're just looking at all the possible outcomes and picking out the ones that have 2 boys. This one, and this one. Those are the only 3 that have 2 boys. So there's the sample space and the answer for number 8. Those are all the possible outcomes where you have 2 boys and 1 girl. Now, if we wanted the probability of that, which is number 12, the probability of getting 2 boys and 1 girl, well, all we're doing is saying, well, there's 3 possibilities with 2 boys and 1 girl out of the 8 total possibilities. So the answer to number 12 is just 3 out of 8. So that would be the answer to number 12. This would be the answer to number 8. And number 10 is just saying, list the elements of the event that the Lins have no girls. Well, there's only one possibility where there's no girls, and that's, of course, where you have all boys. The probability of that would be 1 out of 8 if you were asked for the probability of that. So the sample space for 3 children is this. The sample space for having 2 boys and 1 girl after 3 children is this. The sample space for having all 3 boys is only 1 outcome. And number 12 is just the probability of getting 2 boys and 1 girl. And that's 3 possibilities out of the 8, which gives us our 3 out of 8. All right. So another very interesting application of this probability is dice, right? A lot of times we use dice, we use cards, we use a coin to explain these basic probabilities. So let's say we're rolling two dice, right? So on the first die, you can either get a 1, a 2, a 3, a 4, a 5, or a 6. And on the second die, you can either get a 1, a 2, a 3, a 4, a 5, or a 6. And if we look at all the different possibilities here, and like we were talking about the counting principle, if there's 6 possibilities for one die and 6 possibilities for the other, well, we're going to have 6 times 6, or 36 total possibilities. All right? We can roll a 1 on the first die, a 1 on the second die. Let's put the total number that we're going to get here. So total out of the 2 die. Total sum of 2 dice. All right, so 1 and a 1 is going to give us a 2, 3, 4, 5, 6, 7. Right? If we roll a 2 and a 1, we get a 3. If we roll a 3 and a 1, we get a 4. If we roll a 1 and a 2, we get a 3. And you can easily see how this table is going to be filled out. Let's quickly go through our table here. And this is the total, right? So 1 die, 1 through 6. Second die, 1 through 6. The numbers in the table are the total when we roll 2 dice. So if we look at, let's look at, I don't know, number 26. Okay, number 26 on page 716 asks us, it says two regular six-sided dice are tossed. Compute the probability that the sum of the pips, we're calling these pips, the dots on the dice, compute the probability that the sum of the pips on the upward faces of the 2 dice is each of the following, in this case, 12. All right, so we're looking for the probability that the sum is 12. Well, there's only one where the sum is 12, where you get a 6 and a 6, double sixes, right? Double sixes give us 12. We said there's 36 possibilities, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 rows of 6. So 1 out of 36 would be our answer there for the probability of 12. If we wanted the, the probability of a 5. Well, probability of 5 looks like 1, 2, 3, 4. These are the dice itself. These aren't outcomes, right? So we're just looking at the body of the table, 1, 2, 3, 4. So the probability of a 5 is going to be 4 out of 36, or 1 out of 9. And you can calculate any probability for any of the numbers. Notice 7 is the most common, 1, 2, 3, 4, 5, 6. 12 is the least with 2. 2 and 12 only occur 1 out of 36 times, and all the rest you can easily find the probability of all those numbers. If you add them up, you're going to get 1, right? Because you got to get somewhere between a 2 and a 12. So dice, coins, cards are things we often look at. All right, then one more here. Let's look at a dodecahedral die, which is a 12-sided die. So now we're rolling, this is number 20 and 22. If we're rolling a die that has 12 sides, well, there's 12 possibilities, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there's 12 possibilities. So 12-sided means 12 possibilities. 12 possible outcomes. And we're just asked again, just like we were with the other dice, probability questions. Well, if there's 12 possible outcomes, 1 through 12, the probability that it's not a 10, well, that's one outcome. So there's 11 other outcomes. So our probability is going to be 11 out of 12. Right? 11 times when we roll that 12-sided die, we're not going to get a 10. Right? 1 out of 12 times, we are going to get a 10. Pretty simple stuff. And, it doesn't matter how difficult the question becomes. You're just kind of thinking it through. So same dodecahedral die, 12 outcomes. What's the probability that we get a number less than 5 or greater than 9? So less than 5 is going to be 1, 2, 3, or 4. And greater than 9 is going to be 10, 11, or 12. So 4 possibilities here, 3 possibilities here. Out of 12, the probability is going to be 7 out of 12. Right? So probability is really just common sense. You're just looking at the number of possible outcomes and the number of outcomes that you're specifically interested in, forming a ratio and coming up with the appropriate fraction. It's always going to be a fraction, right? Probabilities are always going to be a number between 0 and 1. Probability of 0 means it never happens. Probability of 1 means it's certain to happen. Notice all our probabilities are numbers between 0 and 1. All right, so that is 12.3.